Welcome. Linear Programming Introduction. In this video, we shall be talking about linear programming, and at the end of this lesson, learners should be able to define linear programming model, state the characteristics of linear programming, state basic assumptions of linear programming problem, state applications of linear programming. I'm Abdullah Akwemi Falade, Operation Research Facilitator. So this video is meant to get you involved in linear programming, an introductory part to linear programming. Let's talk about linear programming. What is linear programming? Linear programming deals with optimization. It's simply an optimization tool. And when we said optimization, we mean maximization of benefits, which could be profit, it could be sales, it could be revenue, etc. And minimization of cost, time, limited resources, and anything we can try to minimize at any point in time. So linear programming deals with optimization of a function of variables known as objective function. And this objective function is subjected to a set of linear equalities or inequalities known as the constraints. So meaning that in every linear programming problem you must have an objective, and your objective is either you are maximizing profit or benefit, or you are minimizing cost, time, or resources. And this objective will be subjected to some constraints which are meant to be linear equalities or inequalities, but most often it is inequalities. Linear programming is a mathematical technique which involves allocation of limited resources in an optimal manner on the basis of a given criterion of optimality. So, linear programming is mathematical in nature because it involves solving linear equations, linear inequalities, which represent the constraints under which the objective function is constructed. And this is meant for us to get allocation of limited resources in an optimal manner on the basis of a given criterion of optimality. So linear programming is also a technique to determine the best utilization of limited resources to reach a desired objectives, which is either maximizing benefit, such as profit, or minimizing costs. So the take home at this point is you should know that linear programming is an optimization tool that involves maximization of profit or benefit and minimization of cost, subject to some constraints. Now we move. What are the characteristics of linear programming? The first is the objective function must be well defined. In the previous explanation, I explained what objective function is. Your objective function has to be well defined. It's either you are maximizing or you are minimizing. So objective function is a function of decision variables subject to satisfying constraints. So every objective function must be subjected to some certain constraints. So if you are maximizing, your maximization can be achieved under a particular constraint. And so there must be alternative course of action. The second characteristic of linear programming is alternative courses of action. So there must be alternative course of action, one of which achieves the objectives. One of which do what? Achieves the objective. Meaning that out of your constraints, one of the constraints will help you. One of the constraints will help you to come up with something that will be realistic in determining the optimal course of action. Though all others will be involved, but one will take it integral part or critical part to help you to make the best optimal course of action. So the additivity of resources and activities, the sum of the resources used by different activities must be equal to the total quantity of resources used by each activity for all the resources individually and collectively. So we mean that when you have people that are engaged in different activities, so the sum of the resources they use for these activities must be equal to the total quantity of resources used by each individual for all the resources individually and collectively. So another characteristic of linear programming is linearity. That's why the name linear programming comes in. So there should be linearity in your objective function, there should be linearity in constraints. So what do you mean by linearity? In a mathematical sense, it means that the variable involved, the decision variable involved must be of degree 1, polynomial of degree 1. It must be of polynomial of degree 1. So that's just in a mathematical expression. So what we mean by linearity means it has to be something that can be represented on a straight line. So the objective function and the constraint should be something that could be represented on a straight line, something linear. Non-negativity of decision variables. So your decision at the end of the day shouldn't be negative. You shouldn't have a case of minus 20 chairs, minus 30 tables. So if you have to make a decision of producing chairs and table that will maximize profit, you can't at the end of the day advise us to produce a negative chairs or negative table. So in that case, your decision variable must not be negative. So that's what I mean by non-negativity of decision variables. And lastly, we have single valued expectation. Single valued expectation. So resources and activity are known with certainty. Thus, deterministic programming is obtained. So it has to be a single valued expectation. So basic assumptions of linear programming. This is somehow related to the characteristics. The first one is certainty. The coefficient of the decision variables in linear programming are assumed with certainty. Your profits will be certain. The contribution and amount of resources required per unit are known constraints. Divisibility. Your decision variable can take a fractional value. It could be a decimal number. It could be a fraction because we can convert from fraction to decimal. So it is feasible to have fractional value in the resources and production activity in linear programming. We can have 0.5, 0.75. We can have a fractional value. Non-negativity. Your decision variable cannot be negative. Cannot have a negative value. So your decision variable cannot have a negative value. It is not possible for a company or an establishment to produce a negative items. Additivity. It means that the total of all activity equal to the total of each individual activity. You will notice that it is somehow related to the characteristics. Proportionality. So we are sure that proportionality exists in objectives and constraints, meaning that if you are using two items to get 10 output. Definitely, when you have 4 items, it's going to produce 20 outputs. If 2 items produce 10 outputs, 4 items will produce 20 outputs. So there should be a proportionality in the objectives and the constraints. So now let's look at applications of linear programming. What are the areas where we can apply linear programming? We apply linear programming for production mix problem. We apply it in diet problem. Nutritionists use the knowledge of linear programming to solve diet problem. Linear programming is used for advertising, promotion planning, product promotion, incentives to drive sales. You can also use linear programming for investment planning. It helps the investors to know where to invest their money, their resources, for them to get the required results. It helps in production and inventory, the stock. So how do you use linear programming? For production planning, for inventory, so that you'll be able to give the best to your customers, you'll be able to give the best to your clients. You won't experience stock out. You won't have a cases whereby your customers need your service or they need your product and they couldn't find it available. Optimal cargo shipment. We use linear programming in aviation company to have an optimal cargo shipment. So also they use it for optimal cargo shipment. They use it in aviation, whereby they try to see how to manage the passengers' cargo. So the 7th one is multi-period problem with subcontracting option. You can use linear programming when you have such situation. Strategic and military effectiveness analysis. Like you are aware that operation research was as a result of research on military operations. So definitely linear programming is of use for military effectiveness analysis. We also use linear programming for manufacturing. When you need to manufacture, you should know the required quantity you need to put together to have a particular output. We also use linear programming for agricultural application, for farm economics and management. Other applications include military application, production management, production planning and blending problem, financial management, portfolio selection, and profit and planning. For market management, we use it for media selection, for physical distribution and others. We also use for personnel management, which are mainly used by the human resource managers and talent acquisition personnel. They use it for job evaluation, for job performance, to measure the HR metrics, to come up with HR metrics with a certain SKUs or KPI. It is being used in education, in administration, in awarding contracts, for capital budgeting. Government can use linear programming for capital budgeting if they are trying to embark on any project, and others. If you are watching this video for the first time, do not forget to subscribe and press the notification bell to enjoy more videos. I have some practice questions for you. Dash is the mathematical method for solving a large class of special problems which one is attempting either to maximize benefit while using limited resources or to minimize cost while meeting certain requirements. Dash technique used to determine the best utilization of limited resources to reach desired objectives of either maximizing the benefit, which could be profit, or minimizing the costs. Dash function of the decision variable subject to satisfying the constraint. Dash means the sum of resources used by different activities must be equal to the total quantity of resources used by each activity for all the resources individually and collectively. I hope you have learned one or two things in this video. Please watch out for the next video where we shall talk about linear programming formulation. How do you formulate a linear programming problem from a real world scenario? Thanks for watching and bye for now.